Hey, what's going on, folks? It's Mike here, and welcome back to the Modern C++ series. In today's lesson, we're going to continue looking at the standard template library and looking at C++20's std format. Now, I've looked at this in the previous two lessons, so those will be really helpful, but I'll give you a brief review here as we look today at how to print out custom types. So let's go ahead and draw your attention under the general utilities library here. You'll find format, again, which is a C++20 feature, so you need to make sure that you have a compiler that supports that, and definitely use the standard C++20 for the compilation flag. If that's not already the default for your compiler. So anyways, let's go ahead and just take a brief look at format here. I'm just going to go ahead and open it up here. And if we scroll down, we'll go ahead and see what this does here. Again, it just gives us a really nice way to print stuff out. Again, just doing a replacement wherever you have the curly braces for whatever parameters or the arguments that follow after here. And again, you could do interesting things here with positioning, setting alignment, precision, all those different things that you usually use with streams, with the IO manipulation libraries, for instance. But you get the advantage, as we found previously, that format can often be, or it's said to often be faster. You might want to run that through Quickbench. But in my opinion, it is just a little bit cleaner here. Now, with that said, we are going to have to support for our own custom types some way to print things out. And that's very similar to the way that you'd otherwise just write the operator and overload the two stream operators here, but we'll have to end up writing some functions to do that with format. Luckily, it's not too bad. We just have to understand how to do it here. And just to demonstrate this as a use case, let's just go ahead and create a type here, like a point. I'll keep it really simple here with an X and a Y. So let's say this is a point 2D, something like that. And let's create point 2D, and we'll just call it P here. And just to really simply set up here the values here. I don't know, just pick some random floating point values. And I'll go ahead and just clear this. And oops, let's go ahead and add a semicolon, compile this. Okay, so we got a point here. Now, again, if we're going to try to use the std format here, and let's just go ahead and say point is, and then I'll go ahead and put the curly braces. And I could do something like point.x here. Let's just go ahead and demonstrate this, point.x. And let's put an end line here. So not too bad here as far as what we want to do here. And of course, this is going to work just fine here. Again, make sure that you're using a compiler. For me, that's at least G++ 13 or 12, I think, is needed. And then make sure you're compiling with at least C++20. You're going to see me start using maybe 23 now, a little bit more frequently, just as we've evolved throughout this series. But anyways, you can do this here. And, you know, I could do something like, you know, I could put in, again, p.y, and I could now do point is. And let's go ahead and put a comma here so it's nice. Something like this. Oops, let's rebuild it there. Rerun it. And you get a nice output there. Okay, so it's not too bad. Still overall, you know. But what's going to end up happening is if you're someone who's writing a library, let's say, and this is something that lots of your programmers are going to be using, it's probably nicer if you could just put point is and then just one of these, and let's just get rid of all this noise here, P here, okay? That's what we want to eventually be doing. That's our goal here. So let's go ahead and compile this. And you're gonna see that we get some compilation errors. Now I wanna go ahead and show you these just so we can kind of get a hint as to what we're gonna need to implement here. And CPP reference is gonna help us, so don't worry. And I'm gonna simplify it a little bit for us today as well. Let's see, so this is where we started here. And you're going to see here there are like requirements. Okay, it's required. Let's see, in the instantiation, something about checking with a char and a point 2D. I mean, this is kind of the template stuff that's kind of nasty to play around with. But it's complaining about basically something with format here. A static assertion failed because remember these are checked at compile time. There's some compile time checking here for these, which is really cool. And again, I think that's where we're getting our speed performance from in general with std format. Again, I haven't confirmed that with like a very scientific experiment, but that's just sort of what I've seen in presentations from folks who are smarter than me, I guess. But you should always do your own experiments anyways. But you'll kind of start noticing and picking up some stuff. There's something like, okay, this parse thing's missing. Use of deleted function in formatter. Okay, so it's saying we don't have like something available, and it's looking for something with formatter and a type here. And then ultimately, over my shoulder here, I'll move out of the way for a second. It's got this like missing parse thing or something. So, I mean, these are a little bit of hints as to what's missing here. Okay. So let's go ahead and implement this though. Let's figure out how to do this. And if you've been watching my series on design patterns, which is available here, I'll just switch for the writing an iterator from a scratch perspective here. If you remember, we had to write some like special operators and functions, okay, that would be looked at in the default overload. So that's basically the same thing that we're going to be doing here. So what I'm going to go ahead and do here is let's go back to the formatting library. And I'm going to look at this formatter here. Okay, let's make this a little bit bigger. For formatter, defines formatting rules for a given type. Okay, so that sounds like something that's going to be important for us. If we actually look at this, there are various specializations for us for basic types. Here they are, standard specializations for the library types. So we've got things like time, chrono, specializations here. Again, I'm looking at the specializations here. If you haven't seen my C++ videos, again, on this same playlist that you're watching now, you can check out the ones for like partial template specialization and template specializations. That's what we're doing here. We're writing our own specializations so that we know how to format things with this library. Okay, so it's not too bad overall here. And again, you'll see some of the other things here like various containers and so on. And if you watch my previous video, you'll again observe that a lot of these things are for the containers, for instance, like C++23, and you'll see like ranges and stuff. So that's what we need that. And you'll even see like C++20 stuff, 26 stuff is kind of coming in here. Okay. So we need to write our own formatter here. Okay. So there is an example of this. And just to break this down here, let me make it as big as possible. Basically, the pattern is going to be we create our own type, which we already did with point2d. And then this is the specialization that we're going to set up here with our template. We're going to create a struct. I like creating a struct for these too. And I think I did the same thing for my iterators, if you watch that video, because we need a public parse function that could be called, and we need a public format function, okay? So this is going to be the first chunk, and this is going to be the second chunk. Now I'm going to simplify this a lot, and then we'll look back at this example if you want to do, fancy stuff for your different types here. But let's just get a custom type formatted here, and then that'll leave us in pretty good shape here. Okay, so with that said here, let's go ahead and start by creating a new specialization here for this template, and this would be struct stood formatter and the type here, point2d. The second part here, let's go ahead and see what that is here in formatter. It's going to default to character. I believe that's sort of like the, let's see what exactly this is here. Sorry, let's make this a little bit bigger here. So T, I think that's the type here that we're sort of specializing or creating so we can use the standard format for. And let's see here. I think T is like the iterator, or how we're going to iterate through like each of the different characters for the thing that you have. I think this is most important. Somebody can correct me if this is wrong here. I think it's if you want like the wide characters or other types. Those are the character formatters. So that's my understanding. I'm just going to let it default to char for this example. And I think that'll be good for you for most of your examples as well. Okay, so let's go ahead and work with that here. And then let's scroll down here. Basically what we need is, again, in these two pieces here, okay? So what's this first part here, the parse? Well, let's go to the whiteboard here just briefly. Parse is basically as it sounds, right? So if I've got something like my format string here, so standard format Oops, sorry, format. Okay, let's write that a little bit nicer for you guys. Format, just so we're being professional. And I've got my, like, I don't know, point or something, colon, curly braces, okay, and then my point P here. What is parse doing? My understanding of it is, and let me give it a different color here. There we go. This is what we're parsing here, the curly braces, okay? So do you remember when we had format and let's see if I can find it again. I think it's in the spec or something. Specification. Sorry, I just want to go ahead and give you the, here it is, standard specification. You remember this thing here, where we talked about fill and align and optional and stuff? Or maybe just let me refresh your memory. That's this thing here, right? Where you look at this and you're like, okay, it looks like some alien language at first, but, you know, we kind of worked through to figure out that this meant, you know, we're going to fill with this and then align it to the left or to the right, to forget which way this goes. But that was the basic idea, right? And we had this positional argument at the front if we wanted to repeat these things. This is what we're parsing here, right? So if I have this and then maybe like a position and then some symbol here, and I could just make up this symbol. Let's just put like a $sign here or something. I want to be able to have some iterator to go through this context here, okay? So iterator moves through some context, okay? And again, I'm just giving you my understanding the best that I have it here, but that's the idea here, okay? So I know how to parse this thing, because again, this is the power of this format thing, that you can, when you create your type and some other programmers using your library, they can print it out in different ways, like a debug mode, a give me everything mode, or whatever. I'm just gonna work with these, like the curlies here today, because I think many of the use cases, that's what you're gonna wanna support if you have some library here. Okay, so let's go ahead and from the formatter thing, let's go ahead and write this parse thing. I'm going to simplify this a little bit too, all this template stuff. Again, let's not forget our C++ here. Let's just use auto here. Now, importantly here, and maybe I'll make a few mistakes along the way, which will be good. But I do want to, you know, make sure that this is const expr, right? So the auto is not going to capture that. So I want const expr auto parse. Again, for this like parse context thing here, we could just cheat auto, but I do need to make sure that I'm doing this by reference here. And we'll just use CTX. That's fine here. Okay. Okay, so let's keep breaking this down here. Again, today I'm going to kind of give you the simplest thing possible. Basically, I want the iterator to figure out where this begins. Again, remember what this is doing here. It's looking at this block here, or at least, again, that's my understanding, or maybe that's a safe way to think about it. Because if I look at this code here, for this formatter, we're looking to say, hey, do we find this like special symbol, this pound symbol? And in one of the cases where we do find it, we do something different. We quote the string. Okay, so we set some state within our struct. Maybe we'll actually do that. I think that might actually be fun. Let's actually do it. Let's just try it. So auto, let's figure out where we begin to parse here. Well, we'll put in the air handling code here, and we'll say if the context is the end, then we just return the iterator here. By default, we should return the iterator. And let's look for a special like symbol here. Let's say if our iterator equals, I'm going to change the symbol. I'm going to try putting a $sign here. Let's see what happens. And we'll just say like special equals true. Okay, so let's just keep some state here. By default, it's going to be false. Okay. And then let's see what else we should do. Then we'll move our iterator along, right? Maybe there's other stuff to look at here. Okay. Yeah, that's sort of building out the format string. Let's go ahead and capture our errors if we have any. So I'm going to make this a little bit smaller just so we can see this here. And let's say, okay, if it equals the context end and the iterator is not equal to the right curly brace because we found like extra garbage, well, we could throw an error, sure. Format error. And again, whether or not you want to do this, let's say invalid args, something like that here. And we should put the type here, 0.2D, just to give a hint here. And maybe there's other ways to handle these errors, actually. You might want to, I need to think about this. I mean, I think this is trying to do things in const expr so at compile time. So I guess this is okay. Maybe we don't worry about like performance things or whatever. But let's try this much. Let's just see what happens if we compile here. And let's see. Okay, so this is a few spelling mistakes here with the context and our error handling. Handle these one at a time here. Oops. Iter is just it. Okay, great. And then we're getting the rest of this, template madness here, okay? So what am I getting here that's the problem? Again, pages and pages and pages of stuff here. Anytime you get pages and pages of stuff, now that you know that you're working with formatter, we've probably just like not specified something properly here, okay? It should be that stuff goes away if I get rid of this. Yeah, no problem here, okay? So that's a good way to know like your code base isn't blowing up. It's just the format stuff here, okay? Okay, so let's go ahead and work on the next part here, which is this part here, the format here. And this is gonna do the work for us for outputting the actual like quoted version or how to write this out. Now, interestingly, they use a string stream here. I'm going to use a different trick that I've learned. I learned this from a few blogs, and the Professional C++ book, I think, has a little bit different way of this. I'm just going to use this format too instead of this here. Maybe we'll try this. I don't know. I kind of just want to stick to the thing that I know is going to work for you guys and is also correct here. Let's go to the formatting library. Let's use this here. So under our formatting functions, format2 is what I want to use. And that writes out the formatted representation of its arguments through an output iterator, okay? That's what this is here, this output iterator, okay? So maybe behind the scenes it's using that. So again, I'm not sure with the CPP reference example. I'm just going to use format2. And let's see here. Yeah, I guess you could choose the like iterator or maybe how you want to write things out and have total control. I'm just gonna again do something just a little bit different for this parse function here. And again, I'm gonna use the same sort of cheat here. And instead of doing all this template stuff, I'm just gonna do auto here, and it'll deduce that for me, which is nice. Makes the language look a little bit nicer here. Which I think is important when you're doing some of these extra things. When you're considering that you're basically going to have to copy and paste this code. I mean, maybe you could do some like template metaprogramming magic for these things, certainly. But per type, you would have somebody who creates the 0.2D type, and then at the end of that implementation or whatever, you would create this format thing for it so that you could pretty print it nicely. So anyways, what are the arguments going to be here? The type here, 0.2D. I think this could be const ref2. It's not going to change anything. So I just call it P here. And then we need this format context. Again, I'm going to just cheat here and use auto. And this is going to be const here, right? We don't want to change anything. Again, I think we're going to get a bunch of errors. So if we get a bunch of errors coming out, that's probably why here, okay? And then what we could do here is just return standard format2. Let's go to our format2 example. Let's see what it's giving us here. Format2, back inserter. Okay, there's a bunch of overloads for this. Let's see what we've got at the top here, just so I can kind of walk you folks along with what I've got here. Yeah, let's just understand this. This is our output iterator, the format string here, and then the arguments, okay? So this bit should look pretty familiar to, exactly what we were doing with our format string and then the arguments. What's this output iterator thing here? Well, let's go ahead and just look at our the CPP reference, which is a nice job here. I think this format context here is like the output iterator. Let's see, I got to look at this. I think that's how I'm going to get away with using it, but I believe that's the case here. So we could just use that. Okay, so let's go ahead and try that format too. CTX. Let's see here. Yeah, the output iterator. Oh, I see. Let's see here. Format args. Let's see what this output iterator to the output buffer here. Yeah, I think the this context here just has an output here. If you look at examples, that's how I've prepped it, and that should work. But anyways, then the rest of it is just something like this. Let's just put our format string here, p.x, p.y, right? So this part again should look pretty familiar. This is the stuff that we want in our format string, but we're just doing it for the object, however we want it to print out here, okay? And then I'm gonna close that off. Let's compile it. It works. Let's go ahead and see if it works with this example here, and then we'll do our special case here. Program, and it works. Point is 7.3 and 5.5. Now we did have this little special case here with the true thing. So let's, right, and that state that's held into this object here. Let's see, I mean, we could make this as simple as if special, we'll do one version, else, let's do this here. And I don't know what our special version should do. Maybe it should like, just put it in parentheses or something. Maybe something like that. And let's go ahead and do two versions of this. And let's see, what was this little symbol that I tossed in here? A $sign? I don't know if that makes sense for this. Let's just pop this in anywhere. Let's see, does that work here? I think I needed the colon. Let's see, does it complain? Yeah. You do like colon, $sign, cool, and that works. And I run it, and we got our special version and the P version here, okay? And you might have like a verbose version or, a different version, something like that, or a version that, you can do whatever you want. And that's kind of the point of format. The initial reaction, I think, from folks is going to be, this is ugly. I had to write this code. I mean, the truth is you just have to sort of do this once per type here. And you'd kind of do something similar to this, right? If you overload, you would come in your struct otherwise, and you would do the overload for operator this with the stream, okay, which you could do as a member function or a friend function or something. So sort of up to you how you want to do that. In fact, let me just go ahead and do that here, just so we have it all in one video. Let's go ahead and let's see here. Gotta search it. Let's just open a new CPP reference here. Operator, and let's find the operator overloads. Search for it. I know this isn't exact. I think it's useful for us to. This is the one we want, because we want to do output. I think it's just useful for us to be able to compare here. So let's go ahead and do this. So paste. There we go. And what's the type that we have here? It's going to be point2D. And I just want to do like OS, I don't know, like this here. Object X, comma, object Y, close, and I think I can leave it as that here. Let me see. Let's see if that compiled here. Let's see if I remember my operator overloads. Oops, maybe not here. Let's see, what did I mess up here? Point2D, I get the O stream. Let's see here. Return. Oh, maybe just a matter of missing or messed up notation here. There we go. And then I guess with this, you kind of have to think about like, how would I handle special cases? So that gets kind of tricky. So that's kind of nice with a format option, right? It became kind of trivial to just like hold that state in here. And if a lot of this stuff's happening at compile time, const expr, where you're like choosing the right thing to do, you don't really have to worry about this, which is doing like, some kind of like buffered IO operation or whatever here. Or maybe even you could flush out the IO or something. I don't know. I guess there's different ways you could try to optimize this. But that, in that way, the verboseness of this formatter, but being able to do things at compile time as I'm looking at it, is indeed kind of nicer than this. Now, this could be the quick way to just do things, but you do sort of have to think about like, okay, this thing's constant. Make sure you don't mess this up, which is the same thing we had to do here. But hopefully, if C++ 23 and so on is doing a good job, it'll be like super strict with some of these overloads or something, so we don't mess that up. The state, as I mentioned, is very useful. So, you don't have to write a million different versions or think about how to do this. The other thing that you have to kind of do with these ostream functions, if I just write it like a free function here and I want to print out other stuff, I have to make it a friend function so that I can access the private members of this struct, or if you have a class. So again, those are some different little trade-offs that you have. I like this, right? You can reduce this down to something like this. Now, of course, we don't have our special version anymore. I think that's going to error out here. So let's go ahead and compile that and run it just to show you that this will still work, like at a minimum. I'm just trying to answer to maybe folks who are going to say this is too much code to write. I think this is a reasonable amount of code to write. In fact, we don't have the special case anymore, right? So it's just this here, right? You can get it down to like 5 lines here. In fact, I'll copy this example as a minimum just so we can have it here. And then let's put our like, nice example here. So here's the minimum viable formatter, MVF, I don't know. Let's kind of put that here. But that's not too bad. When I start comparing that and thinking about if there are extra performance gains, there we go, even one more line we could get rid of. Not too bad. You can basically copy and paste this, or if you're trying to do like template metaprogramming magic and just automatically generate these for all of your types that you create, or with a macro. I know you can do those, but maybe there's a safer template way to do it. Again, this doesn't start to look too bad overall. In fact, you could probably template this specialization or something and generate these. So anyways, not too bad overall. I like doing, I'm going to start doing this more. I shouldn't say I like doing it because I haven't started doing this too much, but I like that this is a new feature in the language. I'm going to start using format more. I'll try to start using it more in the videos because I think it's a nice thing. So anyways, there you go. There you have it. Here's our code. So now we've gone from, old style C++ to something minimal like this, where we can format and nicely for your custom types, just print everything out. Again, I think this is going to be really important for library writers who are creating types or otherwise want to help programmers using your code just be able to quickly see stuff. I think there's neat things you can do, like having special versions or verbose or debug versions or something of your objects that could also be used here. Alrighty, folks. So anyways, hopefully you enjoyed that video. As always, you could follow along with my various series here, and specifically the C++ series, which you're watching now, and just keep track of your progress, and that way you'll know if you've watched all the format videos or some of these other videos I've mentioned. All right. Alrighty, folks. So anyways, hopefully you enjoyed that. I had a lot of fun exploring that with you. And as always, if you have questions, feel free to engage in the discussion with the community below. I'll look forward to checking that out. Folks have been doing a really nice job with that. And again, I just want to express my appreciation to those of you who have been engaging in whatever form, whether viewing or discussing with your other colleagues, has been great to see. And yeah, with that said, I'll look forward to otherwise seeing you in the next one. And thanks again for your time and attention.